Okay, so this is the second check your understanding that's on page 115. We did this as a bell ringer in class, but I really wanted to use this to explain our different kind of numbers that we did in our note taking. That was number 7, number 8, and number 9. So you're still responsible for knowing those numbers, having 7, 8, and 9 filled out in your notes. So if you were absent and you need some help filling those out, I would get with another student that you trust, or you can ask me, fill them out the best you can, and I can go over them, go over your answers with you. So the check your understanding is on page 115. It starts at number 10. It says, is the number 2 a square number, a rectangular number, or a triangular number? Explain your reasoning. Well, if you remember, number 7 says square numbers are perfect squares. So I'm going to actually just write the number perfect above that so that I know that means numbers that, like, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. And 72 is not a perfect square, so I can eliminate that option. Rectangular is the pattern, I'll write it in pink also, is the pattern n times n plus 1. We got that from number 8. And that just means that whatever number I start with, the very next number when I'm counting is going to be multiplied together. So an example would be 3 times 4, or 4 times 5, 6 times 7. So that's the pattern. And if I think of two numbers that would equal 72, I can come up with that fairly easily. It might take you a couple guesses, but if you do 7, I'm sorry, not 7, if you do 8 times 9, you will get that rectangular number of 72. So I'm going to circle rectangular because my explanation is going to be 7 times 8, right? Those are two consecutive numbers in a row, right? Triangular numbers means that I still have that same pattern of n times n plus 1, but then it's divided by 2. So if I think a number divided by 2 doesn't mean that it's automatically an even number, but if I multiply 72 times 2, so double it basically, and then try to find two numbers that come up with that number, it just doesn't work. So I mean, let me go ahead and show you on a calculator a little bit of guessing and checking that you can do. So if I wasn't sure, right, I know that if I'm going to have to divide it by 2, so I should probably double it to see. Okay, so 144. I know 144 is a perfect square, so I know 12 times 12 will equal 144, but will 11 times 12? No, because we know 12 times 12. How about 10 times 11? No, I'm just getting smaller and smaller. So let's do 12 times 13. Well, I already know that's wrong because it's 12 times 12 is 144. So there's no way I can get 144 with two consecutive numbers because I'm going to have to divide by 2. So it just doesn't work, okay? Now, the next one is number 11, and it says, assume each side of each pentagon is 1 centimeter. What is the perimeter of each figure shown? So this is my figure 1, and it's sad drawing. I'm definitely not an artist. Okay, I did my best without tracing. So 1 centimeter. Sorry, keep turning my book. So 1 centimeter. Figure 1 is going to have 5. Well, it's a pentagon. So figure 1, centimeter, 5 centimeters round. Now figure 2 I'm going to trace because in class a lot of us wanted to count wrong. So 1, 2, 3, 4, 5, 6, 7, 8. Remember that middle piece is not part of the perimeter. Okay, and figure 3, same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11. That answers number 11. Number 12 says, draw the next 3 figures. So I would have to draw figure 4, figure 5, and figure 6. And guess what? Mrs. Kirk is not drawing because it'll be worse than that. But you could do them. I don't judge your drawing. I just want to make sure that you understand the idea here to determine the perimeter of each of these figures. So if I look here closely, I am adding 3 on each time. So if I'm at 11, figure 4, if I add 3 to 11, should give me 14. If I add 3 more, that should give me 17, and if I add 3 more, that will give me 20. And those are all in centimeters, right? And I'm going to go ahead and put those on my chart because the very next question, number 12, says draw the next, number 13, this is number 12. Number 13 says organize the results in 11 and 12 on a table. So now I'm on 13, organizing my table. And it also says what would be the perimeter of the 10th figure. So the 10th figure means I need to keep going. So let's see, if I did the 7th figure, I would have 23. If I did the 8th figure, I'm going to move my 10 down because I don't have enough room. Add 3, add 3, add 3. So the 10th figure would be 32 centimeters. All right, and 14 says use n to represent the figure number. That means I need to write an expression using n that is the rule for this chart. So the first thing I want to check for is a common difference or a constant difference. Okay, if this number is the same all the way down, then that's the number I'm multiplying to my variable n. But it's not quite enough. If I take out and test my theory here, that means I'm going to put a 2 in for n. If I do 2 in for n, that only gives me 6, but I need to have 8. So in order to get 6, to get 8, I need to add 2 more. So I'm going to add 2 here. I'm going to see if that works. So I made it work for 2, so let's go ahead and test again. Let me test the 3 in there. So 3 times 3 plus 2, that's 9 plus 2, which is 11. Oh, that works. Okay, so it works for 2. I'm going to test one more. So in for n, I'm going to try 4 here. That gives me 12 plus 2, which is 14. I found the rule. This is my rule for 14. Done. 15 says use your expression to determine the perimeter of the 15th figure. Of the 50th figure. So if I'm going to do the 50th figure, I need to substitute 50 in for n. So 50 times 3 is 150, plus 2 is 152 centimeters. So that would be a very large figure that I certainly wouldn't want to draw. I'm so glad that I know how to do a little bit of pre-algebra. Okay, so that's the Check Your Understanding on page 115, and I will see you in class.